Good morning, everybody, and welcome to my presentation. My name is Meta Indah Agnestia. I'm chemistry teacher in Semandua Padalarang, West Java Province, Indonesia. The topic of my presentation is green environment. Today, I'd like to tell you about bibliometric computational mapping analysis of publication on augmented reality based green mineral mining module using PhosViewer. I've divided my presentation into four main parts. First of all, I'll talk about introduction. Second, we'll look at method. Third, I'll explain you about result and discussion. And finally, I'll show you about conclusion. So let's get started. Since 2013, learning must be capable of developing students' 21st century abilities, such as integrate augmented reality into learning. Augmented reality, or AR, is a technology that combines virtual and real-world information. The emergency curriculum was developed during the COVID-19 pandemic. Elementary chemistry topic, which is normally taught in 12 level, has to be eliminated as part of the emergency curriculum implementation. Furthermore, human-caused environmental harm is becoming more common, with mineral extraction causing damage to soil, water supplies, and air pollution. Thus, the concept of green mining must be presented to students, specifically through learning models that use AR, to increase their curiosity and encourage. Research on appropriate literature sources is required while constructing augmented reality based on green mining models for minerals. We can use bibliometric analysis to determine the progress of the research area. That concludes my first point. Let's turn now to method. In this study, bibliometric analysis was carried out using PhosViewer on search results for various journals and other scientific works on Google Scholar with the additional application Publish or Perish. Publish or Perish application is used to collect this data in publication period from 2018 to 2023. Then the data processed using the PhosViewer application. The results are in the form of network visualization, overlay, and density. Now let's move on to my next topic, which is result and discussion. 234 items were obtained that meet the criteria based on the search results for journal and other scientific works through Publish and Perish application from Google Scholar. Keywords that are returned are green chemistry, models, augmented reality, green mining, minerals, and limestone. The data was analyzed using PhosViewer and obtained a total number of sites equal 1,000, average number of sites per year equal 48.93, and maximum number of sites per author equal 4,593. Each item is included in 8 clusters. Mineral items, which are red in color and have an occurrence frequency of 252, are included in cluster 1. Augmented reality items, which are blue in color and are included in cluster 3, have the greatest occurrence, namely 280. The overlay visualization findings reveal that the model items have a high score and seem brilliant in color, which is yellow. This is represented by dark blue, the lowest score, which tend to move from brighter to yellow, or the greatest score. Let me expand in this point. The development of augmented reality and the green mining models for minerals research typically decrease, while it looks to have started to grow in 2023. The network's visualization result clearly provide the precious mineral and augmented reality in huge form, whereas the third model is apparent but far apart and little in size. The overlay visualization findings reveal that the model's items have a high score and seem brilliant in color, or yellow, and the density visualization results show that the augmented reality and minerals items have the highest density displayed in yellow. So that brings me to the end of my presentation. Thank you very much for your attention.